It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Very good evening, all of you guys. Just a moment. Chalo, let's start the session. So, how are you all guys? Yesterday class, we have already discussed about what we call the marathon session for the electrical engineering बच्चों के लिए इसी के जो common part है ना वो तो cover किया. So आज अभी क्या करेगा? We will be discussing the remaining leftover part that is for the EC students. Okay. So let's start. Very good evening. Let me inform to your friends that we are live. ओके चलो, सीओ को रिवीजन करने के लिए मैं तो सीओ कोर्स आपने कंप्लीट किया क्या भरत? सीओ का रिवीजन कोर्स में तो प्लस पे किया ऑलरेडी, दैट इज जस्ट 15 आवर्स में टोटल सीओ का सिलेबस. सो अभी आई मे नॉट बी एबल टू डिस्कस द थियरी इन दिस सेशन, बट थोड़ा सा सीओ का प्रॉब्लम्स करता हूँ, ठीक है. सीओ का जो डिफरेंट टॉपिक्स में एक प्रॉब्लम लाया, सो आई विल जस्ट क्विकली रिवाइज इट, बट नॉट ए कॉम्प्रिहेंसिव रिविजन लाइक डिजिटल, बिकॉज डिजिटल का क्या आपने मोस्ट ऑफ द पीपल हियर हैव डन द कोर्स, सो दे कैन कैच. सीओ में क्या बिना कोर्स दे जस्ट केवल रिविजन कोर्स अटेंड किया तो दे डोंट अंडरस्टैंड एनीथिंग. सो आई कैन अंडरस्टैंड दैट, बिकॉज ऑफ दैट ओनली केवल फ्यू प्रॉब्लम्स तो इंक्लूड किया मैंने. चलो लेट्स स्टार्ट द सेशन देन. सो द पार्ट 2 टेक्निकली. चलो, so this is about me. For those who don't know about me, this is Bhima Sankar. I did my MTech from IIT Kharagpur. I have 10 years of teaching experience in GATE and ESC throughout the country. I'm expertised with the subjects of digital circuits, network analysis and microprocessors. In the last 10 years, I taught to several thousands of students like you. I'm able to guide them to reach their destinations in the best possible way. With my experience, let's start the session such that this session will also help for EC students who are aspiring for the GATE 2022, that is the digital circuits revision. So before going further, let me give you some inputs about Unacademy Plus subscription. If you take Plus subscription, you will be getting the classes by top educators of the country, which are live classes. You can watch unlimited number of times, and you have the multiple batches like crash batch, rank improvement batch, comprehensive batch, different batches. You can choose any batch of your choice, and also we teach the regular doubt solving sessions after every 3 sessions, one dedicated doubt session, and complete test series is also free. If you want to go for iconic subscription, you will get a personal digital coach and the corresponding preparatory material and personalized guidance, so that you will be getting a personalized way of guidance. So these are the prices only for today, guys. That is, you will be getting 20% discount on Unacademy Plus subscription. Offer last only for today. So these are your Plus subscription prices. Okay, you will be saving this much, and these are the final prices only for today. Iconic में आपको personalized test performance, study planner, you will be getting the reviews, everything in a personalized way. ठीक है? चलो, this week we are coming live with the solutions immediately after the GATE exam in all our platforms for all the branches. So this exam is going to happen on this Sunday, like every Sunday. So the toppers will be getting, according to the rank, the percentage of the scholarship on Unacademy subscription. Okay. So these are the new batches started recently, today only on Unacademy, that is 2nd February. Okay, you can call to this number for any kind of queries. So these are the batches, foundation and evolve ascend batches, evolve batch ascend. Okay, so if you want to take the plus subscription aspiring for 23-24, you can start. Now my dear 22 aspirants, get ready. कल तो हमने ये complete किया, हो गया ये कॉम्बिनेशनल सीक्वेंशियल डाटा कन्वर्टर्स. अभी क्या बाकी है सर? बूलियन अलजेब्रा, नंबर सिस्टम्स, लॉजिक फैमिलीज. ठीक है, इसके बारे में वी विल बी डिस्कसिंग नाउ. सो चलो, दीज आर द थिंग्स वी डिड यस्टरडे. कम ऑन. Yes, that's all. That's the done. That's where we stop. So now we are entering into the new chapter, the Boolean Algebra. So here actually मैं तो yellow color लाया, but most of our, as you told, yellow is not visible for most of you. क्या करना? When I change the background, it will not work in this platform. थोड़ा सा wait करो. Is it visible? First tell me. I don't think, yeah, it's not properly visible, na? Thank you, Anjali. Okay, yes, 100% not visible. Okay, let me write it again. Okay, I'll write it again. Okay, so all these properties I'll be writing. So Boolean algebra में हम क्या क्या डिस्कस किया, बेसिक प्रॉपर्टीज क्या होता है सर, कॉम्यूटेटिव प्रॉपर्टी, एसोसिएटिव प्रॉपर्टी, डिस्ट्रीब्यूटिव प्रॉपर्टी, सभी लेट मी एक्सप्लेन वन बाय वन. सो कॉम्यूटेटिव प्रॉपर्टी क्या होता है सर, a प्लस बी इक्वल टू बी प्लस ए. सो कौन सा गेट सर सेटिस्फाई दिस कॉम्यूटेटिव प्रॉपर्टी सर, आपका एंड गेट, OR गेट, NAND, NOR, exclusive OR गेट एंड एक्सक्लूसिव NOR गेट, सभी सेटिस्फाई करेगा कॉम्यूटेटिव प्रॉपर्टी. बट कौन सेटिस्फाई नहीं करेगा सर, आपका NAND और NOR, सॉरी आपका इम्प्लीकेशन एंड इनहिबिशन डज नॉट सेटिस्फाई कॉम्यूटेटिव प्रॉपर्टी. वो रेगुलर क्लास में डिस्कस किया. Implication, inhibition are the universal logic, but they does not satisfy commutative property. ठीक है, right? Is it visible in this format or shall I change the page? थोड़ा सा वेट. Is it okay guys? Please comment here. अभी तो ये कलर्स में ठीक है ना, ब्लैक ये तो चेंज नहीं होता है, दैट इज द इशू. ये सॉफ्टवेयर पे आई ऑलरेडी स्लाइड पे है तो इट विल नॉट चेंज, दैट्स द इशू. अदरवाइज आई कुड हैव डन. नाउ इज इट फाइन, विजिबल है ना? हाँ ठीक है, चलो राइट. द नेक्स्ट वन इज एसोसिएटिव प्रॉपर्टी. एसोसिएटिव प्रॉपर्टी तो ये देता है, ये बी प्लस सी, ए प्लस बी पे बी प्लस सी पहले किया, इसके बाद ये ऐड किया, नहीं है तो ए प्लस बी फर्स्ट किया, इसके बाद सी किया, दोनों केस में आपको रिजल्टेंट सेम होता है. इट इज सेटिस्फाइड बाय ऑल द पॉसिबिलिटीज, बट इट इज नॉट सेटिस्फाइड बाय आपका NAND गेट, NOR गेट. एंड गेट और गेट तो सेटिस्फाई करेगा, NAND एंड NOR तो डज नॉट सेटिस्फाई एसोसिएटिव प्रॉपर्टी. ठीक है, ऑर्डर ऑफ द ऑपरेशन, फर्स्ट यू डू बी प्लस सी और फर्स्ट यू डू ए प्लस बी प्लस सी विल गिव यू सेम आंसर इन बोथ द ऑर्डर्स. सेम विद द मल्टीप्लिकेशन ऑल्सो. द नेक्स्ट वन इज डिस्ट्रीब्यूटिव प्रॉपर्टी. ऑल दीज आर द पार्ट्स ऑफ बूलियन अलजेब्रा. ये plus BC equal to, you can expand this as A plus B into A plus C. Similarly, distributive property में ये बोलते हैं absorption. A plus A bar B क्या देता है सर? absorb होके A plus B होता है. बहुत important, बहुत problems में मदद करेगा हमको. And another important one, consensus law. आज नोट्स शेयर करता हूं टेलीग्राम चैनल पे. कॉन्सेंसस ला ये बोलते हैं यू शुड हैव ए वेरिएबल और इसका कॉम्प्लीमेंट एंड बाकी जो होता है ना इसका प्रोडक्ट यहीं पे है, तो ये वाला बाकी वाला प्रोडक्ट को नेग्लेक्ट कर सकते हैं. ये होता है कॉन्सेंसस ला. Another thing we discussed in the Boolean क्या होता है सर? ट्रांसपोजिशन लॉ. ट्रांसपोजिशन लॉ क्या होता है सर? A plus B plus C. What is the answer? Here if you have a variable, इसका complement ऐसा दोनों मल्टीप्लाई किया तो a प्लस समथिंग a बार प्लस समथिंग, देन व्हाट इज द रिजल्ट विल बी a इंटू अदर देन कॉम्प्लीमेंट a बार इंटू अदर देन a. Okay, this is the final answer. The next one, self dual. Okay, self dual का मतलब क्या होता है? A function will be equal to its self dual when f equal to ft. What is dual? डुअलिटी का मतलब क्या? पॉजिटिव लॉजिक को नेगेटिव लॉजिक में, नेगेटिव लॉजिक को पॉजिटिव लॉजिक में कन्वर्ट करने के लिए डुअलिटी मदद करेगा हमको. डुअलिटी इज नथिंग बट कॉम्प्लीमेंट बोथ द इनपुट एंड आउटपुट ऑफ द सिस्टम. दैट इज एंड रिप्लेस्ड बाय आर, वन रिप्लेस्ड बाय जीरो इन बोथ द साइड्स ऑफ द फंक्शन, देन द रिलेशन विल रिमाइन स्टिल सेम. सो एंड गेट रिप्लेस्ड बाय और गेट, वन रिप्लेस्ड बाय जॉन. Positive logic will become negative logic. This is in a function n replaced with r, 1 replaced with 0, function will become its dual. Okay, chalo next time. Okay, now we can make it. Next slide पे कुछ दिक्कत आएंगे तो I will make it clear, don't worry. So the next one is 3 input, बहुत commonly asked question, majority gate. What is its value? याद करना चाहिए AB plus BC plus AC. Right. Now छोड़ दो, don't worry about it. आपको ब्लैक चाहिए? Right. Okay, now it is fine, I think. So let's move for the next thing, that is exclusive OR gate. XOR, perfectly visible now? Yes, it is visible. Okay, what is the meaning of XOR? If your input contains odd number of ones, your output is equal to 1. ठीक है, and हमको पता है A XOR A equal to 0. A XOR A बार कितना होता है सर? 1. 0 XOR with A, आंसर क्या होता है सर? एक इनपुट XOR का 0 किया तो दूसरा इनपुट भी 0 है तो 0 आएगा, दूसरा इनपुट 1 है तो 1 आएगा. 1 XOR with A, what is the answer? A bar. Next, A XOR A XOR A, ये देता है A XOR A 4 बार किया तो 0 देता है. Right, this is about your exclusive OR gate conditions. Here some formulas worth to remember is X XOR with Y XOR with XY equal to X plus Y. ठीक है, it is better to remember this formula because problems में आता है. और XOR gate is called odd parity detector. Odd parity detector का मतलब क्या होता है? When the input contains odd number of ones, your output is equal to 1. Or even parity generator. ठीक है. It is also called as even parity generator. When your input contains odd number of ones, your output is 1, and if you include that one or use it as a parity generator circuit, then total it will make the total number of ones equal to even. So that is about your exclusive OR gate. In the same way, I can give some inputs about exclusive NOR gate. Okay. Here there are two types of. Okay. What is A XNOR B? It is nothing but complement of A XOR B. Okay. But for 3 input and 4 input and so on, we should be careful. Listen carefully. If you have A XOR B XOR C, it can be done by different ways. One method is another method is okay. In this case, what happens? It is AB. ये होता है A XOR B. This is C. ये होता है A XOR B XOR with C. What is this output? A XOR B XOR C. ठीक है, होल बार. इस केस में क्या होता है सर? इफ यू टेक A B and C, it will give you A XNOR B. This will give me A XNOR B XNOR with C. ठीक है. अभी ध्यान से देखो. दिस केस में इनपुट कंटेन्स even number of zeros, output equal to 1. Here odd number of zeros, sorry, even number of ones, output equal to 1. Okay. So here please understand, you can say this one is even parity generator. Okay, and here this one, it is the same as XOR for n equal to odd, and it is a complement of XOR for n equal to even. Actually in IEEE books, IEEE publications, etc., they followed this one. That is, for 3 input case, they took XOR and XNOR are same. But in our GATE exam, some problems they have taken this logic as XNOR is a complement of XOR. Okay, so actual sense there is no standard definition for more than 2 input. Up to for 1 minute, yeah. Up to 2 inputs, okay, fine. Okay, 2 input के में it is complementary, 4 input में भी complementary. For odd number of inputs, we should be careful. Okay, odd number of inputs में depends on the implementation you have done. Okay, XNOR can be equal to XOR also or complementary. Okay, so for 3 input, XNOR and XOR can be same. And remaining rules you can frame in the same way here also. And you know, A bar XOR with B equal to A XOR with B bar equal to A XOR B whole bar equal to A XNOR. Okay, and similarly A XNOR A 1, A XNOR 0, ये क्या होता है? उल्टा होता है भाई. A bar These are the basic rules of exclusive OR gate and exclusive NOR gate. Gate में some questions में this is satisfied, okay, but in IEEE papers also this is also given. Both are correct, originally speaking. In the exam, according to the options, we should take care. So the next one, two-level logic. Okay, so let's discuss about the two-level logic. Okay, so two-level logic में क्या होता है? The basic rules: NAND equal to AND OR, NOR OR AND. Okay, then NAND followed by NOR, AND followed by AND, NOR followed by NAND. ये क्या होता है सर? OR followed by OR. And some important rules from the De Morgan's law. This is equal to this one. NOR is equal to bubbled AND gate. इसको बोलते हैं De Morgan's law. Okay. There is another thing called Shannon law. What is Shannon law? Complement is equal to its one-time dual, comma, individual variable complement. ठीक है? So come to here. टू लेवल लॉजिक्स में और क्या होता है सर? एंड फॉलोड बाय NAND. एंड फॉलोड बाय NAND इज इक्वल टू NAND followed by OR. Similarly, OR followed by NOR is equal to NOR followed by AND. Okay. These are called degenerative forms. What is the meaning of degenerative form? With single gate, many input. What is the form? What is that? OR followed by NOR. This you can write it as 4 input NOR gate. The cases where you can implement the functions with a single gate with more number of inputs increasing, उन वाला लॉजिक्स को क्या बोलते हैं? डीजेनरेटिव फॉर्म्स बोलते हैं. टोटल 8 डीजेनरेटिव फॉर्म्स मिलते हैं अप टू द टोटल 16 पॉसिबिलिटीज. और पॉसिबिलिटीज क्या भाई? एंड एंड हो गया, एंड एंड नॉर, ठीक है, एंड OR followed by NAND. ठीक है, ये दोनों केसेस क्या होता है सर, बबल्स, इट इज NAND फॉलोड बाय AND, दिस इज NOR फॉलोड बाय OR. ठीक है, just using this concept we can use I hope we in the basics we have discussed. This is most important, problems में बहुत help करेगा ये दोनों, SOP POS में it will be helpful a lot. ठीक है, yes, very good. So these are the basic 2-level logics. So SOP POS, minterms and maxterms. Minterms and maxterms का relations क्या होता है सर, minterm and maxterm हमेशा complementary to each other, and if any minterm is there, what is the relation between minterm and a maxterm? For a minterm I is equal to maxterm 2 power n minus 1 minus I का dual, where n is the number of variables. Any function will become self dual. कब होता है भाई self dual? I will explain. If you have a function f of x, y, z, when will you get it is equal to dual? Means f must be equal to f dual, that is nothing but complement both the input and output. This is nothing but FD. FD is nothing but complementing both the input and output. That is, if you take x, y, z and fill the table from the bottom to here, whatever you get from here, suppose you get the k, here you should get k bar and vice versa. Here you get 0 1 1 0, उल्टा से 1 0 0 1 आना चाहिए. ठीक है, suppose if you have in any function I is a minterm, then 2 power n minus 1 minus I must be max term. This is how you can check for the self dual. If this is satisfied, इसका ट्रिक्स भी डिस्कस किया रेगुलर क्लास में, देन कंपलसरी क्या होता है सर, वो सेल्फ डुअल. ठीक है, सो एक्स वाई जेड पे 0 0 0 0 0 1 0 1 0. ठीक है, सो इफ यू हैव फंक्शन लाइक दिस 1 0 0 1, इसका कॉम्प्लीमेंट क्या 0 1 1 0, दिस इज सेल्फ डुअल. Suppose if you have another function 1 0 1 1 1 0 0, it is not self dual. Self dual में क्या होना चाहिए, सिंपली इफ यू अर्धा करो, ऊपर से नीचे जो है ना, नीचे से ऊपर इसका कॉम्प्लीमेंट होना चाहिए. 1 0 0 1 का कॉम्प्लीमेंट 0 1 1 0. यार 1 0 0 1 कोई भी नंबर ले लो और 1 0 0 ले लो, इसका कॉम्प्लीमेंट 1 1 1 0 होना चाहिए. नहीं हुआ ना. So if it is like this, not a self dual function, it's like this, तो self dual function होता है. Okay? चलो नेक्स्ट, दैट इज अबाउट योर SOP POS. SOP हमको क्या करेगा, सम ऑफ द प्रोडक्ट्स विल हेल्प यू. मिन टर्म्स विल वी यूज मिन टर्म्स इन द SOP, मैक्स टर्म्स इन द POS. SOP POS will represent the same function in two different ways. They are not what we call complementary. Min terms and max terms are complementary to each other. Okay, so the next one is K-map. Okay, so if you have n variable K-map, some points worth to remember I am speaking. Okay, बहुत basic how to draw a K-map I don't discuss in the this session. N variable K-map, the output expression contains maximum 2 power n minus 1 terms. We call it as a prime implicants in the output. Not okay. So somebody yesterday asked me, sir, explain about implicants, prime implicants. He is there now. उनका नाम मैं तो भूल गया. Just a moment. या चलो. सो के मैप में एक पॉइंट आप याद करना चाहिए. आपने एक पेयर किया तो पेयर विल रिड्यूस द साइज ऑफ द एक्सप्रेशन बाय वन वेरिएबल. क्वाड विल रिड्यूस or eliminate two variables. Octet will eliminate three variables. So you can see here, if we group two power m cells, okay, in a n variable K map. ठीक है, आपके पास n वेरिएबल के मैप, इसमें आपने क्वाड ऑक्टेट जैसा 2 पावर m सेल्स ग्रुप किया तो इट विल रिड्यूस ओके m variables okay. Output expression size is reduce means eliminate. It is n minus m bits size. Generally, if you have a n variable K map, every single term is of size of n. ठीक है, आपके पास 4 वेरिएबल K map है तो हर टर्म का साइज कितना होता है? सर 4 होता है. बट अगर आपके पास इफ यू मेक ए पेयर का मतलब 2 पावर 1, इट विल रिड्यूस वन वेरिएबल, देन इट विल बिकम साइज इज 3. ठीक है, लिटरल काउंट बोलते हैं, साइज इज नथिंग बट. ठीक है, नहीं है तो if you make a octet का मतलब 8 का मतलब 2 power 3. Octet will remove 3 variables from the regular size of the expression. Okay? Yeah, POS or SOP में the concept of PI and EPI remains the same. Okay? Next, suppose see here for your example, 4 variable K map. Each term ओके 4 वेरिएबल लिटरल काउंट होता है. सो ऑक्टेट का मतलब क्या होता है सर? 2 पावर 3. सो योर आउटपुट क्या होता है सर? इट विल एलिमिनेट 4 minus 3, दैट इज 1 वेरिएबल. ओके, 1 इज द लिटरल काउंट. इट विल एलिमिनेट 3 वेरिएबल्स. चलो, let's move further. Okay, right. So let me give you some inputs about PI and EPI. Okay, it is formed by grouping maximum possible adjacent cells, that is pair, quad, octet, or single term also when there is no possibility. All these comes under PI. EPI. EPI क्या होता है सर? Okay, all PI need not come in output expression. ठीक है, बट EPI क्या होता है सर? EPI का मतलब मैंडेटरी, कंपल्सरी बोलते हैं. इट इज अ सबसेट ऑफ PI, but it contains कम से कम, that is minimum, one cell, okay, which is not covered by any other PI. If you have a PI which contains at least one cell which cannot be touched by remaining all PIs, it has some cell which is unique to only that particular PI, उसको बोलते EPI. EPI compulsory present in output expression. इसके बारे में हम बहुत क्वेश्चंस भी किया, प्रॉब्लम्स भी किया. फाइन, चलो लेट्स डू दिस क्वेश्चन. आप लोग ये क्वेश्चन सॉल्व करके आंसर दे दो. गाइस राइट? Give a try. Solve this question. नो आंसर यार, क्या हुआ? The circuit shown below, x bar y plus x y bar is where is the circuit here? It is found that input x equal to y equal to 1 can never occur. Okay, for function x equal to y equal to not never occurring. What is the simplified expression? Okay, of x bar y bar z. Function f equal to x bar y plus x y bar z bar. Can I write this as x bar y canonical form में z plus x bar y z bar plus x y bar z bar? ये क्या होता है सर? Sum of the mean terms 0 1 1 0 1 0 again 0 1 1. Sorry, 1 0 0 2 3 4. And there are a don't care conditions. What are they? xy never become 1 means 6 and 7. Y 6 and 7, here x equal to y wala condition. So you need to take the function take a K map x y z ठीक है, इसमें सम ऑफ द मिन टर्म्स 2 3 4, डोंट केयर्स ऑफ 6 and 7. Right, so what is the answer? This will be y plus this will be xz bar. Y plus x into z bar. ठीक है, वेरी गुड. चलो, right, next. Sir, next question. If x equal to x1 x0 y equal to y1 है ना, अनसाइड नंबर्स है, तो ऑलरेडी हमने किया, आप लोग तो करना चाहिए यार. ये तो कल क्लास में मैंने डिस्कस किया कंपैरेटर सर्क्यूट में. So try this question. Good. दे दो यार आंसर. Option D. Let's see. When will you get x greater than y? X greater than y. That's all. 6 बार आता है, मैं कल क्लास में भी डिस्कस किया. ये तो एक क्वाड होता है, एक पेयर, एक पेयर. सो व्हाट इज द क्वाड आंसर? x1 प्लस एक पेयर का क्या होता है सर? क्वाड इज x1 y1 बार. नेक्स्ट पेयर का x0 y1 बार y0 बार. लास्ट पेयर का x1 x0, ये दोनों का कॉमन क्या? y0. ठीक है, मैं तो कैसा फिल किया? x ग्रेटर देन y. दिस इज 1 ग्रेटर देन 0. 1 इज नॉट ग्रेटर देन 1, छोड़ दो. 3 ग्रेटर देन 0 1 2. 2 ग्रेटर देन 0 1 1. ओके, वेरी गुड. नेक्स्ट. राइट, ये तो हो गया ना कल क्लास में. Right. Let's move for the next chapter, number systems. Okay, let's start. Now we are entering into the new chapter, इसको बोलते हैं नंबर सिस्टम्स. नंबर सिस्टम्स में आपको कंपलसरी याद करने वाला पार्ट तो आई ट्रिपली रिप्रेजेंटेशन. आई ट्रिपली रिप्रेजेंटेशन में तो ऑलरेडी रेगुलर क्लास में बहुत बार दिया, बिकॉज इट इज न्यूली इंट्रोड्यूस्ड लास्ट ईयर, सो चांसेस आर देयर दे कैन गिव यू क्वेश्चन फ्रॉम दैट. सो प्लीज रिमेंबर floating and fixed representation. Okay, and do sample problems from previous CSC papers. This is the one I can suggest you or important thing from the number systems which is recently introduced. एक कन्वर्शंस तो सभी लोग करते हैं यार, इसमें ज़्यादा डिस्कशन भी करना नहीं चाहिए. बट द नेक्स्ट वन इज कॉम्प्लीमेंट्री मेथड्स. व्हाट इज आर्स कॉम्प्लीमेंट? r power n minus number, which is 1 followed by n number of zeros minus number, where n is the number of digits and r is the base. What is r minus 1's complement? r power n minus 1 minus number. That will give out to be r minus 1 minus number. Okay. Now, if you need, for example, r equal to 10, your number equal to 1, 2, 3, 4. What is 9's complement? 9999 minus 1, 2, 3, 4. What is 10's complement? In general, 9's complement plus 1. So r's complement is also equal to r minus 1's complement plus 1. What is the advantage of this complementary representation? आप a minus b करना चाहिए तो आप आसान से a plus r's complement of b से कर सकते हैं. Okay, so now let's move further. Right, so then in number systems, another important thing is the codes. Okay, XS3 self complementary. Self complementary का मतलब क्या? Self complementary code. 9's complement is equal to 1's complement. What are the examples of self complementary codes? 2421, 84, minus 2 minus 1, XS3. Right. Another thing is gray code. Okay. If you give a binary number B3, if you do the XOR operation, this is what you got, gray code. Similarly, how to convert gray to binary, for G3 you will get V3, and this you take back and take gray XOR operation with G2, you will get V2, and take this and take this, right? So this is about your gray codes. So this is binary to gray or gray to binary. Right. Now next let's move. Oh, excuse me. Okay. Okay. Next. The next most important one is overflow condition. Overflow condition बहुत important, ठीक है, क्योंकि when overflow occurs, okay, when will you get overflow? Okay, x bar y bar z plus x y z bar, that is where x and y sign of inputs, z is the sign of result. ठीक है, ये तो हो गया. नहीं है तो the carry input to the MSB is not equal to carry output of the MSB, then also overflow occurs, exclusive OR operation लेना. This is the important formula occurred or asked so many times. When what is the meaning of overflow, or you can say another thing is carry output and MSB of result not equal, that is also overflow. Overflow का मतलब signed arithmetic में when the result does not fit into the size, okay, and range of the representations in the number systems. If you have see ones complement में range signed magnitude में, okay, range, ये दोनों का रेंज कितना होता है सर? -2 power n minus 1 minus 1 to 2 power n minus 1 minus 1. What is 2's complement representation range? -2 power n minus 1 to 2 power n minus 1 minus 1. I hope you know, right? Unsigned magnitude, zero to 2 power n minus 1. Okay, these are the ranges of the representations. This also you should better remember. That is, these are the things most frequently occur from number systems, but please better, this part is very important. This year trending part to ho sakte, so please go through it. चलो, that's all about number systems. तो ये क्वेश्चन था यहीं पे. Try this question, tell me the answer. No. EC electrical engineering students, please don't waste your time. अभी तो एग्जाम है ना अवेलेबल टाइम पे. It's only for EC. Okay. EN लोग को आ सकते हैं, ठीक है. So the number n is stored in a 4-bit 2's complement representation as A3, A2, A1, A0, and it is copied to 6-bit 2's complement after few operations as A3, A3, A2, A1, A0, 1. So what is the equivalent of the number? See here. A3, right? So it is nothing but 2n. Okay? No. It is nothing but n equal to this one. You just copy MSB, the number will remain value same again. Now if you make it 2n, what is 2n is just multiply with 2, then it will become just add 0 at the end. Then what is 2n plus 1? Add 1. That's all. Right? Just copy it, the MSB will not change the value. After that, shifting will be multiplied with 2, and lastly 1, 1. One more question. Try this. The base of the number system where 24 plus 14 equal to 41. (24 plus 14 equal to 41. What is the base? Here 4 plus 4 is giving 1, means after 10, 11 will come here. 4 plus 4 is 8. 8 is represented as here 11 or 21 or 31, whatever may be 1. So 8 is directly represented in the base 8. What is 8 here? Because 4 plus 4 is equal to 8 now. In the base 6, what is 4? What is 8? What is 8 here? What is 8 here? So the number 8 can be represented like this. Whichever is satisfying the LSB here, base 7. Understand? 4 plus 4 will give you 8 here. That is nothing but 8 is given as, in place of 8 you have 1 in the LSB. 1 in the LSB means if it is a base 8, directly 8 will come. So no. If it is a base 6, 2 should come. If it is a base 5, 3 should come, because 4 plus 4 will give you 1, 3 in the base 5. So it is the base 7. Very good. You can take base x in the direct method also there, yes or no? 24 base x, 14x equal to 41x. Solve the equation. 2x plus 4, x plus 4, 4x plus 1 equal to is the equation. इसको solve करके भी you can do it. So logic families. In logic families, mostly examiner can give you, okay, from the CMOS, okay, because you have the syllabus पे only CMOS. So take care of the CMOS problems, okay, and semiconductor memories में SRAM versus DRAM. This also you take care. Give it important in the logic families. ठीक है, इसमें I mean याद करने वाला एक पॉइंट भी नहीं है. Just definitions you should know. What is the meaning of noise margin? चाहिए तो फैन आउट का noise margin का मैं तो formulas include किया notes में. It is not visible here, but notes पे it is visible. Okay, I have given the formula, so remember that formula sufficient. Okay, so now थोड़ा सा CO का few questions करता हूँ. सर कंप्यूटर ऑर्गेनाइजेशन को क्या करना, स्ट्रेटजी क्या होना चाहिए सर? सी गाइस, 2 दिन में कुछ नहीं होता है. आप ऑलरेडी प्रिपेयर किया तो ओनली थिंग यू कैन डू इज बेस्ट इज CSC का PYQ. CSC PYQ देखेंगे तो यू विल गेट द, आई मीन नाउ डोंट डू इट. 2 दिन में नहीं हो पाएगा. 1 क्वेश्चन कैन कम, बट इफ यू हैव डन दिस इट इज गुड. मेरा कोर्स है क्रैश कोर्स इन द प्लस फॉर प्लस स्टूडेंट्स पे 14-15 आवर्स में मैंने कंप्लीट किया. इफ यू हैव अटेंडेड दैट, आई होप डेफिनेटली यू कैन आंसर एनी क्वेश्चन. ओके, जनरली आई हैव एडेड फ्यू क्वेश्चंस, सो ट्राई टू आंसर दिस क्वेश्चंस गाइस. द मोस्ट अप्रोप्रिएट मैचिंग फॉर द फॉलोइंग पेयर्स. दिस इज बेस्ड ऑन addressing modes. Addressing mode, if you know it, which particular addressing mode is useful for which particular way of operation is this question. So I am again saying I don't revise CO much, because most of the people you have not studied CO at all. So even I explain also you don't understand. That is the reason. Okay. So but for those who have some little knowledge, just 5 minutes में मैं revise कर रहा हूँ. Indirect addressing is used for the concept of pointers, because without directly having the address of the memory location, we store the memory in a variable. That variable will be doing the job of pointer. Pointer is nothing but a variable which holds the address of another variable. Immediate addressing में we directly load the data, so constants के लिए help करेगा. Auto incrementing, decrementing is indexed mode of addressing पे. This can help you for what we call loops. That is C में loops होता है ना, 100 times एक कुछ काम करना, I equal to 0, I less than or equal to 100, I plus plus, ये होता है ना. In that case, auto increment mode will be helpful. Okay, with the help of indexed registers. So first one, x equal to 2, y equal to 3, z equal to 1. Right. So the next question, if you try to read, consider a hypothetical processor with an instruction of type LW R1 comma LW का मतलब जनरली लोड R1 comma 20 of R2 which during the execution reads 32-bit word. First it will read the 32-bit word from the memory, stores it in the register R1. Okay, then the effective address of the memory location is obtained by the addition of this constant 20 and the contents of the register R2 which so हम कुछ मेमोरी लोकेशन से डाटा लाके R1 पे लोड करेगा. सो विच मेमोरी लोकेशन से लाना चाहिए इज डन बाय विद द हेल्प ऑफ R2 का R2 में कुछ डाटा होता है दैट वन इफ ओनली R2 इज गिवन इसको बोलते हैं इनडायरेक्ट एड्रेसिंग मोड. विदाउट ब्रैकेट्स R2 दिया तो रजिस्टर एड्रेसिंग मोड, ओनली 20 दिया तो इमीडिएट एड्रेसिंग मोड. ये सभी रॉन्ग. ओके, इसको बोलते हैं बेस्ड इंडेक्स्ड एड्रेसिंग मोड, बेस्ड एड्रेसिंग मोड. सो here we add some relative base to the register to give you the effective address. Next question, pipelining से question आ सकते हैं, maybe from the pipelining concept. Comparing the time taken for a single instruction on a pipelined CPU, time taken for non-pipelined. Pipelining का मतलब क्या होता है सर? The total process is divided into parts and in the computer will execute each part in parallel with each other. So while doing the first part of the first processor, the second part of the second part of the first instruction, first part of the first instruction, sorry, second part of the first instruction करने समय पे first part of the next instruction starts doing, so that it can save the time. But when you do only one instruction, single instruction में क्या होता है सर? Pipeline में first instruction will take same time for both pipelined and non-pipelined, but first in the pipelined case pe you require extra registers to store the data in between the stages. So last question for you. You have a 4-stage pipeline firstly, and you have 4 stages fetch. This is one register between them. Decode, you have a register between them. Some execute, you have a register between them, and the memory. Each register is taking 5 nanoseconds. Now this case में the stage delays कितना? 150, 120, 160, 140. Okay, 150, 120, 160, 140. बट हम इस पे मैक्सिमम वाला कंडीशन लेना चाहिए. सो 165. सो डायरेक्ट फार्मूला हाउ मच टाइम इज रिक्वायर्ड इज गिवन बाय k प्लस n minus 1 into 165. Okay, by 1000 will give you, this will give you total time required for the 1000. By 1000 will give you time required. Okay. Nanoseconds. So k is because the first instruction requires total time and the remaining instructions requires only one at a time. So for first case, the number of stages 1, 2, 3, 4 plus 1000 minus 1 into 165. Let me do the calculation. this will give you, this is nanoseconds, right? 165.5 microseconds. Okay, I will explain it little better. See here, in the pipelined case mein, this is how it will happen. First processor is going to happen its execution, then the next instruction will start before the actual completion. The next will start before the actual completion. So the next will start and so on. So first case may it require the serial access of all. After that, every single box will release one instruction. So instead of taking this much time, it takes only one box time. Sometimes examiner will ask you pipeline efficiency. Then if you do serial access, all of them into 1000 times it requires. But now only one box ka time into 999 plus this part. Okay. So that will give you 165 into 4 plus yeah, that will give you this much amount of time. Okay. If you have not studied CO at all, you may not be understanding anything about it. So then in that case, I cannot help you because you can live in that case. Okay, that is about our digital and CO part here. Madevi, just a moment. Yeah, good. Yeah, nothing but instructions. Thank you guys. All the very best for your exam. I hope you do well. Okay, thank you.